Spliced wires should not be considered equal to home runs for several reasons, most notably safety concerns. Spliced wires create a potential weak point in the electrical system, increasing the risk of electrical fires or shocks. Home runs provide a continuous and uninterrupted connection from the electrical panel to the outlet or appliance, reducing the likelihood of such incidents. Home runs are more reliable than spliced wires because they eliminate potential points of failure. Spliced wires can become loose, corroded, or otherwise damaged over time, leading to electrical problems. Home runs are easier to maintain and troubleshoot than spliced wires. If an issue arises with a home run, the electrician can isolate the problem to a specific section of wire. With spliced wires, it can be difficult to determine the exact location of the fault. Junction boxes are unsightly and detract from the overall appearance of the home. Home runs allow for a cleaner and more professional-looking installation. Junction boxes must be accessible for inspection and maintenance. Accessible junction boxes allow for regular inspection and maintenance of the electrical system. An electrician can easily access the connections to verify their integrity and make any necessary adjustments. If an electrical problem occurs, accessible junction boxes enable the electrician to quickly locate the source of the issue and make repairs. The National Electrical Code, or NEC, requires junction boxes to be accessible for inspection and maintenance. This is to ensure the safety and reliability of the electrical system. While seamless vinyl siding may be more aesthetically pleasing, it is still considered equivalent to siding with visible seams because it provides the same level of protection and functionality. Repiping a home with continuous PX tubing is generally preferred over splicing existing pipes together. The continuous tubing provides increased durability and reduces the risk of leaks. Patching and painting a drywall hole is not considered an equivalent repair to replacing the entire sheet of drywall. The patch may be visible and weaken the wall over time. The insurance company should be required to cover the replacement of the spliced wires with home runs. Spliced wires do not meet this standard and pose potential safety hazards. The insurance company should not be allowed to settle for a lower quality of repair that compromises the safety and integrity of the home. Now let's delve into the specific reasoning behind these points, providing a more comprehensive understanding of electrical wiring practices and code requirements. We will discuss the practical implications of using spliced wires versus home runs, focusing on safety, reliability, maintainability, and compliance with the NEC. Firstly, let's examine the safety concerns associated with spliced wires. Every splice introduces a potential point of failure. The connection must be mechanically sound and electrically secure. Over time, vibration, temperature changes, and corrosion can degrade the quality of the splice, leading to increased resistance. This increased resistance generates heat, which can melt insulation and potentially ignite surrounding materials, causing an electrical fire. A home run, on the other hand, is a continuous length of wire from the circuit breaker to the electrical device, eliminating these intermediate connection points and significantly reducing the risk of fire. Secondly, consider the reliability of electrical connections. A properly executed splice should provide a low resistance connection that can carry the intended current without overheating. However, the quality of a splice depends heavily on the skill and care of the electrician. A poorly made splice can introduce significant resistance, leading to voltage drops and unreliable operation of electrical devices. Furthermore, splice connections are more susceptible to environmental factors such as moisture and corrosion. Over time, these factors can degrade the connection, causing it to fail. A home run, being a continuous length of wire, avoids these potential failure points, resulting in a more reliable electrical system. Thirdly, let's discuss maintainability. When an electrical problem arises, troubleshooting spliced wiring can be a time-consuming and complex process. It may be necessary to open multiple junction boxes to trace the circuit and identify the location of the fault. This can be particularly challenging in older homes where the wiring is not well documented. With home runs, the troubleshooting process is much simpler. Because each circuit is a direct run from the panel to the device, it's easier to isolate the problem and make the necessary repairs. Moreover, accessible junction boxes, while required by code, can become a maintenance burden if there are numerous splices scattered throughout the electrical system. Regular inspection of these junction boxes is necessary to ensure the integrity of the connections. Fourthly, code compliance is a critical aspect of electrical work. The NEC sets standards for safe electrical installations, and these standards are enforced by local electrical inspectors. The NEC requires that all splices be made in approved junction boxes and that these junction boxes be accessible. This requirement is intended to facilitate inspection and maintenance of the electrical system. The reason behind the accessibility requirement is that electrical connections are potential points of failure, and they need to be readily accessible for inspection and repair. Covering up junction boxes with drywall or other building materials would violate this code requirement and create a safety hazard. The NEC also specifies the types of connectors that are approved for making splices. These connectors are designed to provide a secure and reliable electrical connection. Using unapproved connectors or making splices outside of junction boxes is a code violation and can create a dangerous situation. Now, let's address the insurance company's argument that the spliced wires meet code and should be acceptable. While it is true that properly spliced wires in accessible junction boxes meet the minimum code requirements, this does not necessarily mean that they are equivalent to home runs in terms of safety, reliability, and maintainability. The homeowner's policy states that the company is liable to repair the property with the equivalent materials, bringing such to the same general condition as existed just prior to the loss, or replace the property with substantially identical property. The argument here is that spliced wires do not meet this standard, as they represent a lower quality of repair compared to the original home run wiring. Furthermore, the analogy to seamless vinyl siding is relevant. While siding with visible seams may provide the same level of protection, it is not considered equivalent to seamless siding in terms of aesthetics and overall value. Similarly, spliced wires, while meeting minimum code requirements, are not equivalent to home runs in terms of safety, reliability, maintainability, and overall quality of the electrical system. It is essential to consider the long-term implications of using spliced wires versus home runs. While spliced wires may provide a temporary solution to get the home back in operation quickly, they can create potential problems down the road. The increased risk of electrical fires, unreliable operation of electrical devices, and the added maintenance burden all contribute to a low quality of electrical system. In contrast, home runs provide a safer, more reliable, and easier to maintain electrical system that will provide years of trouble-free service. In addition to the safety, reliability, and maintainability concerns, there is also the issue of potential future problems. As homes age, the electrical system can become overloaded due to increased use of electronic devices. Spliced wires, particularly those that are not properly made or maintained, are more susceptible to failure under increased electrical load. This can lead to overheating, voltage drops, and even electrical fires. Home runs, being a more robust and reliable wiring method, are better able to handle increased electrical loads without compromising safety or performance. Moreover, consider the potential impact and the value of the home. A home with a properly wired electrical system is more valuable than a home with spliced wires and numerous junction boxes. Potential buyers may be concerned about the safety and reliability of the electrical system and may be less willing to pay top dollar for a home with spliced wiring. Home runs provide a cleaner, more professional-looking installation that enhances the value of the home. The insurance company's obligation is to restore the property to its pre-loss condition. This includes not only meeting minimum code requirements but also ensuring that the repair is of equal quality to the original installation. Spliced wires, while meeting code, do not meet this standard and should not be considered an acceptable alternative to home runs. The insurance company should be required to cover the cost of replacing the spliced wires with home runs to restore the electrical system to its original condition. There are specific sections of the NEC that address the requirements for splicing and terminating conductors. For example, NEC Section 110.14 covers electrical connections and states that connections shall be made so that the completed connection is mechanically and electrically sound and provides a reliable electrical contact. It also requires that conductors be spliced or joined with splicing devices identified for the use. NEC Section 300.15 covers boxes, conduit bodies, or fittings where conductors are spliced, joined, or terminated. This section requires that a box or fitting be installed at each conductor splice point, outlet, switch point, junction point, or terminal point. It also requires that all boxes be accessible. NEC Section 314.29 covers the accessibility of boxes and conduit bodies. This section states that boxes and conduit bodies shall be installed so that the wiring contained in them can be rendered accessible without removing any part of the building or, in underground installations, without excavating more than is necessary to uncover the box or conduit body. These NEC requirements highlight the importance of proper splicing techniques, the use of approved connectors, and the accessibility of junction boxes. While these requirements are intended to ensure the safety and reliability of spliced wiring, they do not negate the fact that home runs are a superior wiring method. Home runs eliminate the need for splices, reducing the potential for failure and simplifying maintenance. In summary, while spliced wires and accessible junction boxes may meet the minimum requirements of the NEC, they are not equivalent to home runs in terms of safety, reliability, maintainability, and overall quality of the electrical system. The homeowner's insurance policy requires the company to restore the property to its pre-loss condition, and spliced wires do not meet this standard. The insurance company should be required to cover the cost of replacing the spliced wires with home runs to ensure the safety and integrity of the home. Let's consider practical examples to illustrate the differences between spliced wires and home runs. Imagine a scenario where a homeowner is experiencing intermittent problems with a lighting fixture. If the wiring consists of home runs, the electrician can quickly trace the circuit from the panel to the fixture and identify the source of the problem. However, if the wiring is spliced, the electrician may need to open multiple junction boxes to trace the circuit and locate the fault. This can be a time-consuming and frustrating process. Another example involves a situation where a homeowner is adding a new electrical outlet to a room. With home runs, the electrician can simply run a new circuit from the panel to the outlet. However, with spliced wiring, the electrician may need to tap into an existing circuit, which can overload the circuit and create a safety hazard. Furthermore, consider the aesthetic impact of spliced wiring. Numerous junction boxes scattered throughout the ceiling can be unsightly and detract from the overall appearance of the home. Home runs, on the other hand, allow for a cleaner, more professional-looking installation. The absence of visible junction boxes enhances the aesthetic appeal of the home. The insurance company may argue that the cost of replacing the splice wires with home runs is excessive. However, the long-term benefits of home runs outweigh the initial cost. The increased safety, reliability, and maintainability of home runs will save the homeowner money in the long run by reducing the risk of electrical fires, minimizing the need for repairs, and extending the lifespan of electrical devices. Moreover, consider the potential liability of the insurance company. If a fire or other electrical incident occurs due to the spliced wiring, the insurance company could be held liable for damages. By insisting on a low-quality repair, the insurance company is increasing its risk of future liability. It is in the insurance company's best interest to ensure that the electrical system is restored to its original condition with home runs. The homeowner should gather documentation to support their claim that the spliced wires are not equivalent to home runs. This documentation may include photographs of the original wiring, expert opinions from qualified electricians, and copies of relevant sections of the NEC. The homeowners should also review their insurance policy carefully to understand their rights and obligations. If the insurance company refuses to cover the cost of replacing the spliced wires with home runs, the homeowner may need to seek legal advice. An attorney can help the homeowner understand their legal options and negotiate with the insurance company. In some cases, it may be necessary to file a lawsuit to force the insurance company to fulfill its obligations. In conclusion, the homeowner has a strong case that the spliced wires are not equivalent to home runs and that the insurance company should be required to cover the cost of replacement. The safety, reliability, maintainability, and aesthetic benefits of home runs outweigh the initial cost, and the homeowner's policy requires the company to restore the property to its pre-loss condition. By gathering documentation, seeking expert opinions, and understanding their legal rights, the homeowner can increase their chances of a successful outcome. Now, let's expand on specific code requirements related to electrical splices and wiring methods, referencing relevant sections of the National Electrical Code, or NEC. It's important to note that the NEC is a comprehensive set of standards, and local jurisdictions may have additional requirements or amendments to the NEC. Therefore, it's always best to consult with a qualified electrician and local building officials to ensure compliance with all applicable codes. NEC Article 300 covers wiring methods and materials in general. This article provides requirements for the types of wiring methods that are permitted in various locations and applications, as well as requirements for the installation of wiring. NEC Section 300.14, for example, requires that the length of free conductor outlets and switch points be sufficient for making connections or splices without stress on the conductors or terminals. This requirement ensures that there is enough wire to work with when making connections and that the connections are not strained or pulled. NEC Article 314 covers outlet boxes, conduit bodies, and handheld enclosures. This article provides requirements for the types of boxes that are permitted in various locations and applications, as well as requirements for the installation of boxes. NEC Section 314.16 specifies the number of conductors that are permitted in a box, based on the size of the box and the size of the conductors. This requirement prevents overcrowding of boxes, which can lead to overheating and other problems. NEC Section 314.17 covers the methods for securing cables to boxes. This section requires that cables be securely fastened to boxes using approved connectors or clamps. This requirement prevents the cables from being pulled out of the boxes, which can create a safety hazard. NEC Section 314.29, as previously mentioned, requires that boxes be accessible. This requirement is critical for inspection, maintenance, and troubleshooting. NEC Article 334 covers non-metallic sheet cable, also known as Romex. This is a common type of wiring used in residential construction. NEC Section 334.30 specifies the methods for supporting and securing non-metallic sheet cable. This section requires that the cable be supported at intervals not exceeding 1/2 feet and that it be securely fastened to boxes and other supports. NEC Article 406 covers receptacles, cord connectors, and attachment plugs, or caps. This article provides requirements for the types of receptacles that are permitted in various locations and applications, as well as requirements for the installation of receptacles. NEC Section 406.4 requires that receptacles be securely mounted in boxes and that they be properly grounded. NEC Article 408 covers switchboards, switchgear, and panel boards. This article provides requirements for the construction, installation, and wiring of these electrical distribution devices. NEC Section 408.36 requires that panel boards be readily accessible and that they be protected from physical damage. These are just a few examples of the many NEC requirements that apply to electrical wiring. It's important to consult the NEC and local codes to ensure compliance with all applicable requirements. Now let's address some common misconceptions about electrical wiring. One misconception is that any type of wire can be used for any electrical application. This is not true. The NEC specifies the types of wire that are permitted for various applications based on factors such as voltage, amperage, temperature rating, and environmental conditions. Using the wrong type of wire can create a safety hazard. Another misconception is that it's okay to overload electrical circuits. Overloading a circuit can cause the wires to overheat, which can lead to electrical fires. The NEC specifies the maximum amperage that is permitted on each circuit based on the size of the wire and the rating of the circuit breaker. Another misconception is that ground fault circuit interrupters, or GFCIs, are only required in bathrooms and kitchens. GFCIs are required in any location where there is a potential for electrical shock, such as bathrooms, kitchens, garages, and outdoor areas. GFCIs protect against ground faults, which can cause electrical shock. Another misconception is that it's okay to cover up electrical boxes with drywall or other building materials. This is a code violation and creates a safety hazard. Electrical boxes must be accessible for inspection, maintenance, and troubleshooting. Another misconception is that it's okay to use extension cords as a permanent wiring solution. Extension cords are intended for temporary use only. Using extension cords as a permanent wiring solution can overload circuits and create a fire hazard. Another misconception is that it's okay to do your own electrical work without a permit or inspection. Electrical work can be dangerous, and it's important to have it done by a qualified electrician who is familiar with the NEC and local codes. Permits and inspections ensure that the work is done safely and in compliance with code requirements. Finally, let's discuss the importance of regular electrical inspections. Electrical systems should be inspected periodically by a qualified electrician to ensure that they are safe and in good working order. Inspections can identify potential problems before they become serious, such as loose connections, damaged wiring, and overloaded circuits. Regular inspections can help prevent electrical fires and other hazards. In addition to professional inspections, homeowners can also perform their own visual inspections of their electrical systems. Look for signs of damage, such as cracked or frayed wires, loose receptacles, and discolored outlets. If you notice any problems, contact a qualified electrician for repairs. Remember that electrical safety is a shared responsibility. By following safe electrical practices, homeowners can help protect themselves and their families from electrical hazards.